The notes of a piano are expressed in a pattern of 7 white notes and 5 black notes, which make up the 12-note chromatic scale, the foundation of all Western music. We can visualize the 12 semitones in a circle, which will create a dodecagon, also known as the chromatic circle. Connecting each of the points will create a dodecagram, which will help us define certain musical relationships, such as musical chords that sound harmonious together. Connecting any 2 points with each other will create the most simplest chord, an interval. Triangular forms represent triad chords, such as major and minor.
Augmented, major, minor, and diminished.
Squares or any four-sided shapes represents tetrachords.
Major 7th, minor 7th, dominant 7th, minor 7th flat 5, dominant 7th flat 5, diminished 7th, and augmented 7th.
Pentagons, hexagons, heptagons, and octagons represent different scales.
Pentagons represent pentatonic scales, hexatonic scales, such as the whole tone and minor half step. Heptatonic scales, the most commonly used scales and modes.
With the dodecagon being the largest polygon to represent the full chromatic scale we started with. It's all geometry that helps us to visualize the relationships between notes. Every tone vibrates at a certain frequency, and every shape has particular properties. Is there another way how shape and sound could be related? Let's think about angles and translate them into hertz. Will it make any sound? For example, a triangle has 180 degrees, which is half of 360, the total angle of a circle and a square. Translated into a sound wave, it equates to F sharp and its octave. A pentagon with 540 degrees is C sharp, which creates the harmonic fifth. And if we continue this with other shapes such as the hexagon, heptagon, octagon, and even 3D solids such as the tetrahedron, octahedron, cube, and icosahedron, they all equate to specific tones that beautifully harmonize together. And suddenly, all of this geometry just happens to create the most beautiful form of music.